Okay, in this inclined plane problem, let's assume that we're going to have, there's a force pulling an object up an inclined plane at an accelerating rate. So let's try to draw the FBD for what that would look like. So I'm going to have an angle of the inclined plane, whatever it is. I have an object on the inclined plane. I have a normal force. Clearly I would have a pulling force. There's no way we're going to accelerate up the inclined plane unless someone's pulling it up there. I have a force going into the inclined plane, which is W cosine of theta. I would have a force going down the inclined plane, which is the other component of the weight sine of theta. And of course, if I'm going up, then I would have friction force also going down. Friction force going down. Okay, so those are all the forces on the FBD. And what do I know? I know that this object is supposed to be accelerating upwards, which means there has to be a net force upwards, which means this pull force has to actually be bigger than this weight sine of theta and this friction force combined. There has to be some net force left over in the up direction. So I can start with that basic premise. F net. There has to be some F net. And it would equal the F pull, which I'm just going to label as F. I'm not going to write the pull. It'd be the F minus mg sine of theta, which is weight sine of theta, and also minus friction force. Okay, now what we're going to try to do in this problem is actually we're going to solve for force, the actual pull force. I want to figure out what the pull force would be. So the pull force should equal F net plus mg sine of theta minus friction force, which would be mu times normal force. We'll write it like that. Wait a minute. It'd be plus, right? F net plus mg sine of theta plus the friction force. Okay. So force should equal F net. What's F net? F net, according to Newton's second law, is ma plus mg sine of theta plus mu times, what's normal force? Well, in this problem, the normal force should be equal to this right here. So it'd be mg cosine of theta. Okay, so that's about as far as we go to make it look good. We could factor out an m here, but there's not really any point for that. So the force that we would have to calculate to make this thing accelerate at that rate, I'd plug in all the stuff for all those things. So I'd have a mass probably. I would have the acceleration rate. I'd already know what that is. And I'd know the angle of the incline, and I probably know mu. So I would put all those things in for that equation and figure out what the force is. Again, these are not equations that you're going to memorize or have on your equation sheet. They are just things that you're going to be able to derive because you know how to draw an FBD and you know whether the thing is accelerating or not. So you know whether the forces should be balanced or they should not be balanced, and you can set up a basic equation and derive what you need to get to. So that's how you figure out force, pulling up an object, accelerating it up at a certain acceleration.